Next, we're going to talk about inequalities. So we're going to go over what an inequality is, how to graph uh, an inequality that's just with one variable. Like it will say something like x is less than 5, or x is between -2 and 7. And then we're going to look at linear inequalities, which has to do with graphing inequalities on Desmos as sort of, it's almost like a linear equation, but it's called a linear inequality. So for, we're going to go over simple inequalities, compound inequalities, and some word problems today. So an inequality, very simply stated, this this example, A is less than B. And you might recall this from earlier grades. Maybe you learned about like the alligator eats the bigger number, if that's how you remember the less than sign. This says A is less than B. Example 3 is less than 8. A is less than or equal to B. That's half of an equal sign and a less than sign. So this is a true statement that 3 is less than or equal to 3. A is greater than B. 3 is greater than 1. That's an example there. Not equals means that there's a line with an equal sign through it. This is a compound inequality. We can say B is greater than A, and C is greater than B, or we could say B is greater than A, but less than C. I like to say this like B is between A and C. 2 is between 1 and 3 is how you could read that. And you can also read inequalities. We normally read from left to right. You can also read inequalities from right to left. So if we look at this top one again, it says A is less than B. We can also say B is greater than A. So if we go to this example, 3 is less than 8. 8 is greater than 3. So we can read them forward or backwards. And then finally, we have or inequalities. A is less than B or greater than C. So sometimes we get two different answers for our final answer. So that would be something like x is less than -1 or x is greater than 1. And we're going to go over how to determine when to write or and when to write a compound inequality like this. So we call this a compound inequality. This B is between A and C. And then this one is an or statement. Okay, so when you solve an inequality, it's the same exact rules as if you solve an equals equation with algebra. The only difference is you have an inequality sign instead of an equals sign, of course. And when you divide or multiply by a negative, you have to switch the sign. That's very important. If you don't switch the sign, it'll give you a false statement. So they solve this algebraically, adding 2 to both sides. -3x is less than 12, dividing by -3 on both sides, and then switching the sign. So notice they switch the sign on that step there, and we get x is greater than -4. So let's see what happens if we plugged in -4 for x. If we plugged it in directly and we said that x is -4, we'd get +12 minus 2 is less than 10. And we get 10 is less than 10. And that's a false statement. So we plugged in 4 and we got a false statement. And that's because x has to be greater than -4. So it could be -3, -2, -1, 0, 1, 2, 3, 4. Could be any of those, but it can't be -4. It can't be -5. Can't be -6. If you need some review on the negatives, if it helps you when we do these problems, it might be a good idea to write a number line here and just write like -5, +5, just to help you maybe remember where the negatives go. Because sometimes students find it a little bit challenging when we have -4 here. We think, what's greater than -4? A lot of students, I shouldn't say a lot of students, but some students might say -5, but -5 is less than -4. It goes to the left of -4. Everything greater goes to the right of that value. Okay, so those are simple inequalities. We just solve them for x using regular algebra. There's two kinds of compound inequalities. The intersection type, where we have x's between a value like this, or a union problem that looks like this. Now, you might see some notation, and if you're learning about this after class as well, intersection is like this, and union is this symbol. So those are just the symbols for what those two definitions mean. But when we have an intersection problem, it's going to be a between inequality like that. When we have a union problem, it's going to have an or statement. Oops, go back here. Let's see if I can do that. Actually, let's keep going. Okay. So this says find the solution set to this intersection problem. So you can solve this problem. You can solve it two different ways. I like to solve it this way on the left. The way on the right sometimes will confuse me if I solve it this way, because when I see two different values, I think it's more challenging to write the final answer like a compound inequality again after you have these two different pieces. Now, if you're really good at that, that's awesome, but I would really suggest using the method on the left. And so the method on the left is basically like saying, now we have three sides of an equation. So we -1 in the middle, -1 on the right, -1 on the left. So we have -3 is less than 3x, which is less than 9. And then we do the same thing, all three sides, divide by 3, divide by 3, divide by 3. And we don't have to change the sign because we just divided by a positive number. So that's our final answer. X is between -1 and 3. Let's quickly go over how we would graph this. So when we graph a single variable inequality on a number line, oops, sometimes I want to not erase that. Great stuff there. So when we write when we just have an X, not X and a Y, or we just have an A or just one letter, we can write our inequalities on a number line. Now we start by identifying our endpoints or our values, and then we have to decide, is it less than or equal to, or just less than? This one's less than. So because it's not equal to, we do an open circle at -1. And then 3, same thing. It's not equal to 3, so we do open circle at 3. And this says x is between those two numbers. So like that. Now, if you wanted to solve these separately, individually, you could solve it and you would get this and this separately. So here, what they've done is they just took this part, put it there, and then the second part, solve it there. So if that's easier for you than doing all three sides, you can write them out separately. So if we look at what happens when we write these out separately, x is greater than -1. So still we do our open circle and we shade everything that's greater than -1. But that would make everything, sometimes this gets erased from me writing on this. So that's all right. That would make it all the way out to there, or make it past the 3. But now we have to look at our second constraint. X is less than 3, open circle at 3, shade everything less than 3. Sometimes students shade above the line. You're not really supposed to do that, but I'm just doing that so you can see a little more clearly where the blue is. But then we want to figure out where these cross exactly. So these cross between there and there. So if you're ever not sure if it's a between problem, you can graph them separately and see if do they cross in the middle? Do they cross in the middle? Or do they diverge? Do they go in two different directions and never cross? When they cross in the middle, we have a compound inequality. If they don't cross, then that's an or statement. So let's look at this next one. It says, find the solution set for these two inequalities. And it gives us an or statement right off the bat. So we have to solve these individually. So we just solve these with algebra. -7 on both sides for the first one. 3x is less than or equal to -2. Divide by 3 on both sides. We get x is less than or equal to -2/3. For the other one, we -7 on both sides. And these are just the two that they gave us. -7 on both sides. We get 2x is greater than or equal to 14. Divide by 2 on both sides. X is greater than or equal to 7. Didn't have to flip the signs because we divided by a positive number for both of these. Now, when we graph these, just to make sure that that's still an or statement, you can graph them. I'll do this one a little bit faster. Here's -2/3. Here's 7. And they can be equal to, so it's a solid dot for -2/3. X is less than or equal to -2/3. So we're going to shade everything over here on this side. And then it says, or X is greater than, let me make this line just a little bit bigger here. It says, or X is greater than or equal to 7. So start at 7, put a solid dot because it's can be equal to 7. And then we shade everything that's greater than. So here we can see these lines are diverging. They're going in two different directions and they're not overlapping or they're not crossing in one region. That's how we know that we have an or statement. All right, so if we have multiple variables, let's look at another one. If we have multiple variables, this says that we can separate it into two different statements. I think that would probably be a good idea. If we don't separate it into two, let's see if we can solve it that way. If we just leave it as one entire statement and we do everything the same on all three sides of our inequality. So that might not be possible. Because if we did, let's see. Yeah, I don't think that that's even possible for us to do that because we could do +9 +9 +9. And then we get 3x plus 14 is less than 5x is less than 4x plus 11. Now, if we divide by 5, then we just get fractions for what x is, and that's not going to help us. So we've got to write this in two different inequalities for this one. So when you have x's on all three sides, you can think of it as just write them out separately. So the first one is here, and the second one is there. Okay, and then after we solve these, we should have an and statement because we were given a between statement to start with. And of course, you can check this if you need to. So after we do all the algebra, see x is greater than 7 and x is less than 11. And you can just do a quick sketch. 7, here's 11. X is greater than 7. That's everything over here. And x is less than 11. That's everything over here. So now because they crossed, we have to look at the region that they crossed at. So that's that region there, and that's what tells us that's an and statement. Okay, word problems. You're probably going to see these on the SAT more frequently than these types of inequalities, but it is good that we went over some ways to solve basic inequalities. So let's look at a word problem. It says John and Pete are at an amusement park and they want to ride the super spinning cyclone ride. In order to ride the ride, your height has to be between 48 and 72 inches. And it says inclusive. Inclusive means that we're dealing with less than or equal to or greater than or equal to inequalities. If Pete's height is 34 inches less than twice John's height, and Pete is allowed to get on the ride, write an inequality to represent John's possible heights. So this has to do with writing out expressions with word problems, which I think you're going to see at least 3 to 5 questions like this on the SAT, possibly more. A lot of them are word-based problems where we have to decide how do we write the variables out. And once you can do that, that's basically most of the work that you have to do for the problem. So it says Pete's height is 34 inches less than twice John's height. So we're saying John's height is X, and Pete's height is 34 inches less than twice of John's height. So twice of John's height is 2x. This is for Pete's height. And then 34 inches less than that is just minus 34. Okay. And it says Pete is allowed to get on the ride. So that means that his height has to be between 48 and 72 inches. So we're going to write Pete's height is between 48 and 72. And then we just solve the inequality. So I think writing out the information is the most challenging part, figuring out what Pete's height is and then what this inequality is. We add 34 to all three sides and divide by 2 to all three sides. Don't have to change any signs because everything's a positive value. And we get x is between 41 and 53. So now we have to figure out what that really means. John's height is x, so that means that his height is between 41 and 53 inches. Okay, so that's the first section on inequalities 27. Now we're going to look at linear inequalities. So we're going to look at graphing linear inequalities both in standard form and in slope-intercept form. So recall that in standard form, that is ax plus, let me change this and see this a little bit better here. That's ax plus by equals c. That's standard form. Slope-intercept form, that's y equals mx plus b. Or if we solve it in terms of ax, by, and c, we would say we minus ax, and we get by equals negative ax plus c, divide by b, everything by b on both sides, and we would get y equals negative a over b x plus c over b. So this is slope-intercept form, and so is this. Basically, just know that you have to use your calculator when you're given a linear inequality or a linear equation. That's probably going to be the best method for this. So a linear inequality can't have anything squared on it. It just has x's and y's. So that's what a linear inequality is. If it's squared, it doesn't count. It's not a linear inequality. So often we want to find the solutions to linear inequalities. So we're given a linear inequality and we want to figure out what are the solutions to that. Now, I'm going to show you what this looks like on the graph, and then we're going to look algebraically and how to determine it with algebra also, because it's important to know both methods so that we can check our work whenever we're using Desmos. So I'm going to graph this inequality. 2x plus 3y is less than or equal to 7. Just click the keyboard there, get to less than or equal to, and you'll see something like this. I'm going to close this out, just hide it so you can see this a little bit better. So here's our inequality. It's all graphed in green here. So this line is what it would be if it was equal to it. But this says that 2x plus 3y is less than or equal to 7. That means that it can be equal to the line. So it could be 2x plus 3y equals 7, or it could be less than the line. So that means it could be this line here, or it could be all of this green shaded area here as well. So there's a lot of different solutions for this inequality. Whenever we have a linear inequality, there's many different solutions to look at. So now we want to find, is 1, 1 a solution? Is 2, 2 a solution? And is negative 4, 5 a solution? I'm just going to type 1, 1, 1, comma 1, and then label that point. I'm going to do the same thing, 2, comma 2, label that point, and negative 4, 5, and we'll label that point as well. Now I'm just going to close that so we can have a little more room to take a look at these and zoom in. So let's take a look now to see if these are solutions. So 1, 1 is a solution. It falls within the shaded green area. 2, 2 is not a solution. It's not in the shaded area and it's not on that green line. And then negative 4, 5, it is a solution. It's exactly on that line there. Now, if we had this and it wasn't less than or equal to, if it was just less than, we put a dotted line instead of a solid line. And if it's less than, it means that it can't be equal to the line. So if this was just less than, we would have a dotted line here, and negative 4, 5 would not be a solution on our line. But because this is less than or equal to, we have a solid line. So negative 4, 5 is a solution on our line. So that's how to check with Desmos to see if the solution is true or false. or if it's within the uh, solution set or not. Now, if you would rather use algebra and it's faster for you, you can do that. So if we check 1, 1, we're plugging in 1 for x and 1 for y. So we just plug those numbers in. And remember, anytime there's a number next to a letter, that just means times. But 2 times 1 plus 3 times 1 is less than or equal to 7. We get 5 is less than or equal to 7. That's a true statement. And so 1, 1 is a solution. And we can see that right here. If we check 2, 2, we get 10 is less than or equal to 7. That's not true. That's why we have the 2, 2 out here. And then for this one, we get exactly 7 is less than or equal to 7. And that's true. It can be equal to 7. And so that's why we see this equal on right on the line there. Okay, so that's how we check solutions if they give us the solutions and want us to find out what those are. And we just went over the graphing linear inequalities, actually. So we graph it just like if it was a normal line. And then we determine, is it greater than or equal to or less than or equal to? If so, if it could be equal, we do solid line. If it can't be equal, we do dotted line. And then this says pick a point to determine which side of the line to shade. So let's look at an example here. Look at a new example. This gives us this inequality right here. And I'm just going to solve it in slope-intercept form, just so we can make a little more sense about what this line is even telling us. And you don't have to do this on the test, but I'm doing this just to show you where the calculator is even getting this answer from. So we minus 4x on both sides. We get 6y is less than or equal to negative 4x plus 24. Divide by 6 on both sides. It's a positive value, so we're not going to flip the sign. And we get negative 4 over 6x plus 24 divided by 6 is 4. And we can reduce that. That's y is less than or equal to negative 2/3 x plus 4. Now we can see this is, if we look at this like it's an equals equation first, we can start with finding our y-intercept at 4, and our slope is negative 2/3. So we're going to go down 2 over 3, down 2 over 3. We can also go up 2, back 3. So that's where we're getting this main line from so far. But now we have to figure out, are we going to shade down here or do we shade up here? And to figure that out, it's a good idea to just choose a random test point that is not on the line. So I like to use 0, 0 or 1, 1. And I know that earlier I said not to use those numbers with the SAT, but you can use those numbers when we're talking about graphing inequalities. So I'm just going to pick 0, 0. X is equal to 0, y is equal to 0. And this is our test point. So we're going to plug those into you can plug it into this, or you can plug it into that. These inequalities are saying the same exact thing. All I did was just change it to an easier to understand form over here. So we're going to plug in 0 for x and 0 for y. Let's just use this equation that they gave us in standard form. So you get 4 times 0 plus 6 times 0 is less than or equal to 24. 4 times 0 is just 0, so is 6 times 0. So we get 0 is less than or equal to 24. And that's a true statement. So because that's true, 0, 0 is on this side of the line, So we're going to shade everything on this side of the line. Now, again, if you look at Desmos and you think this is way faster to do on Desmos, you can definitely use Desmos. So we would just type 4x plus 6y and click the keyboard down here, less than or equal to 24. And then 0, 0 would be our test point, and we can see already that that's where we shade. So that's how you can graph it without a calculator. All right, so some of this we just went over. And that's just another example, checking to see which part we shade using the test point 0, 0. Now, if your line does cross through 0, 0, you're going to want to use a different point than that. So it's got to be, you got to decide is is it going to be above or below the line? Or you can think of it as left to the left or to the right of the line for your test point. This gets a little bit complex, I think, with talking about standard form. Um, so I'm going to skip that part for now. This says determine the intercepts of the line. So this is not just with inequalities. This is with all kinds of graphing problems. To find the x-intercept, we plug in, let me see here, hold on just a second. Yes, to find the x-intercept, I don't know if this is written correctly. I think this is written backwards. Yeah, that shouldn't be like that. This should say x comma 0, and this should say 0 comma y. So that's our x-intercept, and that's our y-intercept. So our x-intercept is we plug in 0 for y to find the x-intercept. And to find the y-intercept, we substitute in 0 for x. And so you can do that algebraically instead of graphing it on the calculator. So that might save you some time if they ask you, what's the x and the y-intercept? So if we want to find the x-intercept, we plug in 0 for y. We get 2x minus 5 times 0 is less than 20. 2x minus 0 is just 2x, less than 20. We get x is less than 10. Now, we just set this equal to it so we can find out what the x-intercept equals. But it's the same basic idea for x and for y. Okay, so that's how we find the intercepts. And you can do this with regular problems. You can do this with quadratics. You can do this with graphs that are to the third power. You can always find your x-intercept by plugging in 0 for y, and your y-intercept by plugging in 0 for x. Okay, so just wanted to talk about that, not really go over all of the steps for that. Graphing this inequality, again, you can use Desmos. That's perfectly okay. And we would get something that looks like that. There's a dotted line because this is just a less than symbol, not less than or equal to. Let's see what else is on. So, yes, I think I talked about this earlier. it's a good idea to leave everything in or to change everything into slope intercept form if it doesn't take you too much time. So solving things for one y makes it a lot easier to figure these problems out. And we just went over how to do the slope a couple minutes ago. So this one is not in standard form now. It's just solving for what 1y is. So we'd start at 4. I think maybe we did this problem earlier. We did it it gave us this in a different form, and then we solved this for what y was. So then we went down 2 over 3, down 2 over 3, down 2 over 3. Same thing as up 2, back 3, up 2, back 3. So that's the line portion of it. We know it's solid line. And y is less than, that just means it's down here. But just to make sure we can use a test point, I'll use test point 1, 1 this time instead of 0, 0. So we plug in 1 for y and 1 for x. 1 is less than or equal to negative 2/3 times 1 plus 4. 1 is less than or equal to 2/3 plus 4. Change this. Well, if you're really good with fractions, this is 3 and 1/3. 1 is less than 3 and 1/3. And that's a true statement. So this is true. That means we're going to shade everything below the black line that we just found for what y was, or what y equaled. Okay, and that's just another example there. Okay, so again, graph your inequalities with Desmos. Make sure to use a test point, and also know the difference between if it should be a solid or a dashed line, and then what those mean.